Hello everyone, my name is Ipista Kunda. I am from West Bengal. I am studying in class 12. Today I will discuss with you about electric field and electric field intensity. So I will tell you, just forget it. Just forget what is electric field, what is electric field intensity. I will tell you a beautiful story. Once upon a time, there was a king who lived in this palace. Then his name was A. Now one day, another king, B, was going through this path, and after some time, he reached at this point B. When he reached at this point, he saw that some soldiers were coming to him. The soldiers came and told B to get out from their region. Naturally, B asked why. Then the soldiers replied, "You are in our area now. You have entered in our region and you are now just standing in the boundary of our kingdom." And they also said, "We will not apply force on you. We are just telling you to get out from our kingdom." So B had not any soldiers. So he left the place. Now come here. I take a positive charge here. This is a point charge. And I take a Q0, that is a test charge, and put it at the position P. The Q0 says me, "Hey guys, I am experiencing a force in this direction. But I can't see anyone. So who's doing it?" Then it comes to know that it has entered in the kingdom of this source charge. The kingdom. It is the kingdom of the Q, the source charge. And this kingdom is known as the electric field. Due to this source charge. So what is electric field? So electric field is a space. Electric field is a space around the charge in which another charge experiences a force. It was Michael Faraday who first told about the electric field. Now see here. If I say that B was standing at this point Q, then what would happen? Then we saw that the soldiers came and started to apply a big amount of force on B to get B out of their kingdom. Similarly, in this case, if I take this Q0 and put it at this position, it says me that it is now experiencing a high amount of force. So, from here we can conclude that with the increasing of distance R, the R is increasing, then the force applied by the soldiers on B is decreasing here. And in this case, with the increasing of the R, that means the distance from the source charge, the electric field is decreasing. With the increasing of the distance from the source charge, the electric field is decreasing. Now, if we see here, the king was not going himself to get B out. He only sent the soldiers, and the soldiers will apply a force to get B out. In this case, similarly, the plus Q charge, that means the source charge, is not directly interacting with this Q0, that means the test charge. It is only generating or radiating an electric field around itself, and this electric field is applying the force on this test charge. So it is the concept of electric field. Now here's the question: when does the electric field occur? So we have to remember that the electric field has its own existence, and it is present even if there is no charge to experience the force. Now here is another question, that what is a test charge? So test charge is a charge which has very small magnitude, so that it cannot generate an electric field and it cannot affect the electric field due to this source charge, and also it cannot affect the source charge. So it is called as the test charge. Then we observe that for plus Q charge, the electric field is like that. That means radially outwards. And for minus Q charge, it is radially inwards. For minus Q charge, it is radially inwards. Now we move on to the next concept, the electric field intensity. What is the electric field intensity? I take a charge plus Q here, and I know that it is generating an electric field like this. I take a test charge Q0, which is positively charged, and put it at point P in the electric field of Q. It is a point charge. The distance between Q and P is R. So electric field intensity at a point is defined as EP vector equals to F vector by Q0. That means electric field intensity at point P is equals to the force experienced by this test charge by the magnitude of this test charge. If I put Q0 equals to 1, and if we assume that it is a positive charge, so we can say that EP vector is equals to F vector. That means electric field intensity at a point is nothing but the amount of force experienced by a unit positive test charge when it is taken at that point in the electric field of the source charge. Then now we have to calculate the electric field due to a point charge at a point. So I take a point charge plus Q here, and we have to calculate the electric field at the point P. Electric field is a vector quantity. So for this calculation, our first step is to take a test charge and put it at the point. The distance is R. Then we have to calculate the force acting between these two charges. So we will apply the Coulomb's law. The magnitude of the force is equal to 1 by 4 pi epsilon naught if the medium is air into Q0 by R square. Then the electric field, the magnitude of the electric field at point P is equals to 1 by 4 pi epsilon naught into Q by R square. What is the vector form? E vector equals to 1 by 4 pi epsilon naught into Q by R square into R cap. What is the R cap? R cap is the unit vector along the R vector. Now what is the direction of R? What is the direction of electric field? So in this case, the plus Q, I take charge plus Q, and it is generating an electric field like this. I take a test charge and put it at the position P. Then we can see that it is experiencing a force in this direction. And we can also see that this source charge is generating the electric field also in this direction. Electric field is a vector quantity. So we can say for this case, F vector and E vector, as we assume this is positive charge. When this is positive charge, the force of repulsion will occur. So force, the F vector and the electric field E vector will be in same direction. But if we put the value Q0 is in negative, then F and E will be in opposite direction. Now, if we plot a graph between E and R, electric field and the distance, then we get a graph like this. That means with the increasing of the R, the electric field is decreasing. With the increasing of the R, the electric field is decreasing. If I say that R tends to infinity, then E tends to 0. But if I put the value of R equals to 0, then what will be the electric field? So in this case, we have to remember that at the particular position of the point charge, R equals to 0. That means the particular position of the point charge. So in this position, the electric field will be undefined. The electric field is undefined at the particular position of the point charge. Now I have taken a problem. That is, here is a 5 microcoulomb point charge, and we have to calculate the electric field due to this point charge at the point P. And the distance between the charge and the point is 50 into 10 to the power minus 2 meter. So we will apply the formula. So electric field at P, the magnitude of the electric field at P equals to, the medium is air, 1 by 4 pi epsilon naught into Q by R square. This is the Q. Now the value of this is 9 into 10 to the power 9 into 5 into 10 to the power minus 6, because 1 microcoulomb equals 10 to the power minus 6 square by 50 into 10 to the power minus 2, that's whole square. And if we calculate, the answer will be 1.8 into 10 to the power 5 Newton per coulomb. This is the unit of electric field. And what will be the direction? The direction is like this, because it is a positive charge and it is radiating outwards. It is radiating electric fields outwards, like this. So it is at first, here is electric field. So what is electric field? It is the space around a charge in which another charge feels a force. first point. The second point is for positive charge, it is like this, and for minus Q charge, it is like this. And then, with the increasing of the distance from the source charge, the electric field, with the increasing of the distance from the source charge, the electric field is decreasing. Now, here is electric field intensity. So electric field intensity is E vector equals to F vector by Q naught. Q naught is the test charge. Then the electric field at a point due to a point charge. Q is a point charge. If the medium is air, the third point is the graph. This will be like this. So it is the mind map of the whole concept. So it is the basic concept about electric field and electric field intensity.